Hey y'all, it's Foggy again. We are finishing up our deck. I decided to replace the railing. How do we space our balusters correctly? And how many balusters do we actually need in each section? By the time I got all of our sections laid out, some of the sections were a little bit different lengths. The code here is 4 inches or less between each baluster. So what I wanted to do was distance here should equal this distance here. What I did is I sat down and I came up with a formula, kind of a math formula, an algebra formula that you can plug your numbers into and get the amount of balusters that you need in that section due to code. When you're done, you get that first measurement. You'll be able to mount that first baluster at that distance that we get, and then 4 inches every other one until your last one, and then that last distance will equal the distance of your first one. So here we go. Start this process off, we need 2 measurements. First measurement is from deck post to deck post, and we're going to be going at 40.5 inches. So that's 40.5 inches. And then we're going to need the distance, the thickness or width of our baluster, and it's right at 1 inch. So 40.5 and 1 inch, and now we're going to take our math to the table. How many balusters do we need for the code distance? And the way we do this one is it's pretty simple. It's pretty straightforward. What we do is we already know our total distance of the rail. We call it TDR, and that was 40.5 inches, right? And then we know the width of each baluster, and that was 1 inch. And then we know our code. So our code, in this case, is less than or equal to 4 inches. So we plug that into a little formula, and that's TDR will be divided by the width of the balusters plus the code, and that'll give us how many we need. So number needed. So what we got is 40.5 divided by 1 plus 4 equals 40.5 divided by 5, and that's going to give us 8.1. Now with this, what we're going to do is we're going to simply round to that whole number. So now that we determined that we need 8 balusters, 1, 2, 3, 4, 5, 6, 7, 8. Now we want to know how do we determine the space right here, there's our question mark, and our space right here to be equal from one deck post to the other deck post. Now we're going to find those that equal distance on each side of those up against the deck post with this formula. This formula is it's really straightforward. You plug your numbers in that you already have, and I'll go through each step here. First thing, we know our total distance of the rail, the total measurement is 40.5. We know that the total banisters that we're going to use are 8, and the code is 4. So this is our formula, TDR and all this. So we're going to plug it in. So 40.5 minus total banisters is 8 plus total banisters minus 1, and then our code is 4. We're going to divide that by 2. Now the reason that we got the minus 1 is because with this spacing, you notice something, you're always going to have one more space than you do balusters. So 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So you have to account for that by that minus 1. All right, so now lastly, we're going to go ahead and solve this. So now we know that at each end of these will be 2.25 inches Now let's go and we'll actually put the first baluster on, measure it to that 2.5, and then 4, 4, 4, and we'll see if our math holds true. I'm just going to simply mark that. So now I got just a little bit of a spot there. So that's going to be the edge of it. That's our edge. Right there we go. That's that. So there's the first one. And now the next one, we'll use our matrix. So the matrix goes in just like that. Slide right up against it. Nice and neat. It goes in. Let's see what we got. Okay. Good. Okay, now let's measure. See where we are. All right, right at 2 1/4. So there we are. So here's the final measurement that we did on this thing, finishing this deck up. I was able to maintain 4 inches in each one of these spaces per code, and then I was able to have the end, the last baluster and the deck post, last baluster on this side and deck post, to be equal. And remember, we said it was 2.25, and we're right on 2.25 there. Turn around this way, and we're right on 2 1/4 there too. So the math works out really well, and you know, it's just one of those things that that you don't have to do it that way, but hey, it helps you just sit down inside, plug the numbers up, and it all works out nicely. Now I have another little math formula that I'll go over real fast for you, just in case you want all of these to be equal distance from the deck post and each other. I have a quick one for that too, and you know, and that's really good. That the one I'm about to show you is really good if you have deck sections that are all equal, and mine were not. That was our problem. So so instead of having everything just completely off, the majority of these things were 4 inches, and then the end between that last one and the deck post, they were different, but they were equal on each side. So it kind of works out symmetrically. But I'll show you that the math formula for that one if you want them all spaced absolutely the same distance from each other and from the deck post. If you wanted equal distance of all the spaces, meaning if your deck sections from post to post were all the same, unlike mine for whatever reason, but what if they were all the same and you wanted each space to be equal between each one of these guys? Well, I got another formula for you. And again, you're going to use your total distance of your deck rail, which we already knew was 40.5 right here. And then you've got your total number of balusters, which we've already done. We've already figured that out, how to come up with those, times your baluster width, each one of those, which was 1 inch, over total number of spaces. So we've got it right here. You can see how this works. So 40.5, which was our measurement, minus 8, because that was 1. That was 1 times 8. up here because that was 1 inch. And then over your spaces, total spaces, you've got 9 spaces. Remember, you always have 1 extra space more than you do your baluster because you got a space on each side. And so that works out to be 3.61 inches.
The lawnmower over here, that's the size of a 747 cutting a yard that's about a 10 by 10, so it's a little loud right now. An airplane? Really? Really, an airplane.